Hi everyone. Let's look at this problem from WebWork where we're discussing the net change. It says a projectile fired downward from a height of 142 feet reaches the ground in 2 seconds. What is its initial velocity? And because this says net change theorem, you may have recognized that we're looking for the definite integral. Change in the height is 142 feet downward. And this occurs over an interval of 2 seconds. So I'm going to take that information, and I know that h of 2 minus h of 0 is equal to negative 142. The net change theorem says that because dh dt is equal to v of t, then I'm going to have that this h of 2 minus h of 0 is also equal to the integral from 0 to 2 of v of t dt. Is equal to the definite integral 0 to 2 of v of t dt, because it was equal to negative 142 and it was equal to this definite. Now, if I had a v of t, I would be good to go. I'm going to go ahead and tell you what v of t you should use. The formula for a falling projectile, the velocity of a falling projectile, is v of t is equal to negative 32 times t plus whatever your initial velocity was. So I'm going to take this formula that I'm telling you, you can trust me for now, and I'll explain why it's the formula later. Negative 142 is equal to definite integral from 0 to 2, negative 32 times t plus the initial velocity. Now you say, I don't know what the initial velocity is, and that's exactly right, because that's what we're trying to figure out. That is exactly what we want to know. Let's just keep going forward and see what would happen here. So this is going to be equal to an antiderivative of this evaluated at 2 and 0 and subtracted. In other words, if this is my little f of t, I'm looking for my big F of t. That would be big F of 2 minus big F of 0. I can apply power rule here. Negative 32t, the antiderivative, or an antiderivative, would be negative 32 over 2 times t squared by power rule. And then this v sub I is just a constant. It's a number. I don't know what it is, but it's just a number. I'm going to have v sub I times t. So I can actually take that and plug in the 2 and the 0. So f of 2 will become negative 16. This negative 32 over 2 is 16. So this is negative 16 times 2 squared plus vi times 2 minus, and I can plug in 0 and I get negative 16 times 0 squared minus vi times 0. Now this whole expression, it turns out when you simplify it, it's just equal to 0. So let's not worry about it anymore. And so what I have now here is negative 64 plus 2 vi equal to negative 142. This is an algebraic thing. I can just solve this now for my initial velocity vi. So this is adding 64 to both sides, and we get negative 78 is equal to 2 times vi. That means that vi is equal to negative 39. Now, as a reality check, this number should definitely be negative. And the reason is, if we go back to the initial problem, what we see is that the ball is moving downward and it fell. So anytime you have a ball that's moving downward and reaching the ground, you're going to have a negative velocity.